Hello, so it's just gone over to 12:05, so I think we might get started. So nice to meet you. My name's Catherine, and I'm going to be today's LaTex trainer. A little bit about me. I'm a third year. I'm majoring in maths, and a little bit about today's workshop is, so this is an intermediate workshop, so we hope that you have like a little bit of LaTeX experience, but if not, that's okay. And we're just going to be focusing on the applications of like mathematics here. So we're going to learn how to typeset equations. We're going to use math mode, and we're also going to look at some math packages that we add to LaTeX. And a little bit about how we're going to run the session is it's super casual, so you can feel free to interrupt or put any questions into the chat. And I'll also like do some demonstrations, and you can feel free to follow along, but I'll also allocate some time at the end of like each segment so that you can practice your skills by yourself. So this is an experience poll, but normally if we're doing it online, I just kind of ask if people have used LaTeX before. So if you haven't ever used LaTeX before, I would say just maybe pop it into the chat. That way I can go over some things that you might already know if you've used it before, but it's no big deal if you don't have any LaTeX experience. And the next thing that we need to do is get Overleaf up. So if you don't have an Overleaf account, what Overleaf is it's just a LaTeX editor, but you can access it online. And university students get, or people with a university account get Overleaf Premium for free. And so if you don't yet have an Overleaf account, please let me know so I can allocate some time for that to get like downloaded and set up. But if you do have an Overleaf account, I'll just pop on over to Overleaf. And what we kind of want to do today is we'll just start with a blank project. I'm just going to call it typesetting. So we'll create that. So I'll give a little bit of time for people to hop on to Overleaf. And if at any point I'm going too fast, please let me know, because it's quite easy to speed ahead and ramble on when it's online. So when we open up our blank Overleaf project, this is what we will be seeing for the first time. Just a few quick things. If you pop on over to settings, which is the Overleaf logo button there, you just want to make sure that autocomplete, auto close, and code check are all on. It should come all on by default, but it's good to have it on because it will definitely save you a lot of time. So the first thing that we need to do to our document before we can do any sort of math or equations is we need to add some math packages. And so what is a package? Well, if you've been to the past workshops, or if you have a little bit of understanding of LaTeX, you can see that we already have a package that comes pre-inserted. And this package is what allows us to add images into LaTeX. So we need like plenty more to be able to do like all those math symbols that you'll see. So I've got some saved here. And what I'm going to do is I'm going to copy and paste these into the chat so that you can add it to your Overleaf. So what do we do with these? So we just copy and paste it. And I'm just going to pop it right under the use graphics for images. Oh, there's use graphics twice. I'm going to delete the second one. So we've got AMS math, fonts, symbols, and theorems. So what they do is as you can see in a lot of like math equations, you've got like special symbols like maybe the sigma for summation, like limits, stuff like that. So it just allows us to access those symbols. And I think AMS is like the American Mathematical Society, but yeah. So what the other thing I'm gonna do is I'm gonna delete this line of text there because it's just a comment. I'm going to grab all of these packages and put them into what we call a style sheet. So the way we do that is we just go up here to create a new file. And I'm going to name this style sheet. Style sheet.sty. You have to make sure it says .sty. That's how you let like the compiler know this is a style sheet. And you might be wondering, what is a style sheet? Well, a style sheet can hold like multiple packages at once. So I'm just going to copy and paste that over to here. And then to use our style sheet, we use the same command that is like use package. And it's just /use package and style sheet. Yeah, so I'm going to write a comment about that. So the commenting character is the percentage. So this line of code allows access to all the packages in the style sheet. It's a good idea to keep like all of your packages in one style sheet because you kind of want to keep this main text document as neat looking and as readable as possible. So as you can imagine, if you've got like lots and lots of packages, this main text here, that it gets pretty cluttered. So this is just good practice so we can like condense it all down into one line of code. Okay, so now we've got our document set up, we can actually start typesetting some math. So what I'll do is I will show you our first thing that we want to typeset. So we just want to typeset this, like the limit f of x equals a. And we're going to do this in something called inline math mode. And I'll show you what that means. So I'll make this a little bit bigger so it's a bit clearer. Okay, cool. So I'm going to name this section inline math mode. Just hit recompile there. There we go. We've got inline math mode. And I think, sorry, this is a document I prepared earlier with the images up. I wonder if, because I would like us to be able to see what we're trying to typeset, but that's okay. So the way that we access math mode is we use a $sign. And basically everything in between these two $signs are in the inline math mode. So if you type something like math related outside of that mode, it won't recognize it as you trying to type math. It will just be like, oh, they're trying to type words. Okay, so in these two $signs, we have to use these commands. So the command for limit is \lim. As you can see, every command in LaTeX starts with these backslashes. And then to get the like subscript here, we use the underscore character. Curly brackets are our grouping elements. They basically, they work like as a normal bracket, but they won't show up in the code. So now we want x maps to infinity. So x is just x. Maps, that arrow is \maps to. And then infinity is \infinity. As you can see, yeah, without like any vowels. let's recompile that just to see what it looks like and make sure we're on the right track. Okay, so we've got x maps to infinity. That's all looking good. One thing I will say is you don't have to memorize like all of these. A lot of them, like a lot of these commands, like backslash limit, it's pretty intuitive, but I will give you a cheat sheet really soon so that you don't have to remember all of it. So limit and then f of x. Okay, so that's done. So the reason we call this inline math mode is basically if I write a line of text, this is a line. Okay, so I've written a line of text. You can see that the math is like perfectly flush with that line of text. Because alternatively, if we want the x maps to infinity to be like below the limit, like the way we see here, we can do something at the start. This command called display style, backslash display style. Recompile. Yeah, so as you can see, if we use this command here, backslash display style, then the math is no longer perfectly in line. So I'm gonna make a note about that so that we can keep it in our heads. If you recall, this is the new line character. Okay, so inline math mode makes equations perfectly flush. We can use display style command to alter this. Okay, so I'm gonna recompile that. Oh, this is a little bit squished, isn't it? There we go. Just make sure that's a good size. That's a bit small. Okay, just shout out if it's hard to view. Okay, so we've learned our first math mode. Our second math mode is called display mode. So this is for like displaying equations that aren't going to be within text. So when you say, like sort of when you go, if I have an example here, oh well, I'll show you. But the difference between the last math mode and this math mode is whilst this math mode is good for like embedding math within text, the display mode is more for standalone equations. So I'm going to start a new section. I'll just name this display mode. Let's hit recompile. Okay, we've got our section ready. So display mode is accessed via an environment. If you've been to the earlier workshops, we've seen an environment for an image, but it's okay if you haven't. So an environment is something that has these two commands. It always starts with begin and it always ends with end. So you imagine it as like a sandwich, and then everything in between begin and end is going to be formatted a specific way. And the name of this environment is called equation. Okay. As you can see, when I type, it's like auto-filling for me. So it's like really time efficient. So really advise you to have auto code on. If we look at this, like between our begin and end equation, everything that we type in here is going to be like recognized as the equation. And once again, as I've said in the previous workshops, LaTeX doesn't recognize spaces. So it doesn't matter if I have like this much room or like this much room, it's going to be rendered as the same thing. And so let's have a look at what our goal was. Our goal was to typeset this summation 1 over n squared. Cool. Okay, that sum is the command backslash sum. And then you can see it's kind of showing me what it's going to look like visually. To do the subscript, like n equals 0, we use the underscore character, use brackets here. So everything in this bracket is going to be under the sum, and we needed to put n equals 0. And now to get to the part that's infinity on top of the summation, we use the superscript character, like the caret. I'll use the curly brackets again, and backslash infinity. And now we just want to do 1 over n squared. To do a fraction in LaTeX, you use this command backslash frac. Two curly brackets, like this is the numerator and the denominator. So 1 over n squared. A quick note about the curly brackets is whenever you see curly brackets, it means that this command takes a mandatory argument. Sometimes you'll see square brackets, but we won't get too much into that now. But let's hit recompile and see what that looks like. And yeah, there we go. So there is, and you can see it's like its own standalone environment. This, I'm gonna write this is some text. What that would look like in between text. One quick thing to note is this tag there. You can see it's been tagged as equation 1. If I have another equation, I'm just going to copy and paste this, even though it's the exact same equation. You'll see that becomes equation 2. This is really great because LaTeX will like keep track of what equation is what, and you can reference it later on. But if you don't want this, you don't want them numbered, you can do this in the begin and end bit. You use an asterisk right after equation here. Make sure you do it with the begin and the end. And I'll hit recompile. And then, yeah, that makes it unnumbered. So the asterisk makes equations unnumbered. Yeah, well, that is not how you spell asterisk. There we go. So I know this might be all very fast. I'll give us a little bit of time to resettle. So hopefully that has all not been too crazy so far. Oh, sorry, I didn't see. When you typed in, oh, sorry, I didn't see this message. When you typed infinity or sum, how could you get the symbol to show up? Well, it doesn't display on my overleaf. Oh, okay, Helena. Have you, okay, this might be so, oh, hi.
Hi. So what I mean is like the symbols do show up when I recompile,
Yeah.
but when you type it, I saw that at the bottom in the autofill, it had the symbol like
Oh,
infinite. My
yeah.
one doesn't seem to have that.
Like it does that.
Yeah,
Um,
but that's okay if it's some special
I
setting.
let me have a look. It should be in one of these settings. Are all of these on for you?
Uh, Autocomplete is on, brackets is on, and code check is on. Yeah,
Oh, okay. Because I don't know if I've like
added in. That
hmm.
kind of thing. Oh, but all good.
Okay, I'll look into that. I didn't realize it didn't appear for everyone.
Yeah,
Um,
my one just has the CMD. So like if you type infinity, your one has like the oh
yeah, like the actual image, right?
yeah,
Yeah,
yeah, I don't
that's a
have
lot more
that.
helpful, I think.
Yes.
Okay, I'll research into that, but
Oh, no worries.
yeah, I didn't realize it didn't appear for everyone. Oh.
Oh,
Um, are you all good if we move on to the next section?
yeah, all good. Thank you.
Okay, sounds good. Okay, so the next little bit was this is like another equate environment. So very similar to the last environment. display mode. The downside of display mode is you can't display more than one equation. So we've got this bit here, as you saw before, to display like another equation, I had to like copy and paste it, do a whole new environment. So if I start a new section, I'm gonna call this the align mode. So the align mode is basically, it was invented to support like multiple equations in one environment. And the way we do this is begin, and in here is align. As you can see, the like goal type thing we're going to typeset is just two equations, but they're stacked on top of each other. So let's do that. Let's go f of x equals, and then it was sign first. Sign is just backslash sign. And then it was, I think, 2 pi n. Pi is just backslash pi. A lot of the Greek letters are just their name, but backslashed, so that makes it easy. And then n. And then over here, to get a new line, we have to use our new line character. It's just double backslash. And then we repeat the same thing, but for cos. So f of x equals backslash cos 2 backslash pi n. Okay, let's just hit recompile and we'll see what that looks like. Okay, so as you can see, it's been typeset well, but the important thing about the align mode is we can align things however we want. And the way we do that is with the ampersand character. So I'm going to place the ampersand character like randomly in 2 spots. You'll need to put the ampersand character once per every new line. And what it does is it just like centers the ampersands together. I'll show you what I mean when I recompile it. Yeah, as you can see, like I've set this part of the equation to be the center and then this part to be the center. So now it's like lining up weirdly, but let's fix that and let's get them to line up together. Yeah, so I'm gonna write the ampersand is alignment. And even though right now, if we don't use the ampersand character, it still lines up pretty well. You'll get like long equations, like if I put this in. Like you can sort of see that's not lining up quite how you'd like it. So with the help of the ampersand character, we can really customize how we want it to look. So I'm gonna chuck like ampersand here, ampersand there, ampersand there. And as you can see, that's a lot nicer looking. Another thing to add about the align environment is in the same way that we could use the asterisks here to get the numbers to go away, we can also do the same thing. So let's have a look at our unnumbered equation. Unnumbered, yeah, just gotten rid of the numbers. Another cool feature that we can use in both align or equation is the tag command. So I'll just show you. Let's go tag equation 1. So the tag command just goes in front of the double backslash. Just hit recompile. Oh, why have I used, oh no, wrong brackets. Sorry, guys. So the command is backslash tag and then the curly brackets. Let's have a look. Oh no, we've gone all the way back. Yeah, so you can customize the label of the equation basically. You can make the tag anything you want. So I'm gonna go hello world. Yeah, so, oh, I've put the tag in the wrong place. Let's see. I wanted to label the second one, hello world. Yeah, so as you can see, then later on when you're referencing like, oh, instead of referencing equation 1, you can reference like hello world. So that is like another cool feature. So that, and I'll write a note about that as well. Tag command can be used to custom labels. I'll just hit recompile. I'll zoom out a little bit. This is not the best. Okay, there we go. Okay, so those I think are the main modes in math. Like with these modes, I'm pretty sure, I feel like you can typeset pretty much anything. One little thing that I wanted to add was brackets. Now, this might seem like a weird topic, but comes up quite a lot. So I'm going to start a new section and call this dynamically aligned brackets. You'll see what I mean in a second. Okay, so if I just typeset something like in my equation mode, I'm going to typeset sign, backslash sign, brackets, and then fract pi on 2. There we go. So just something very simple. As you can see, these brackets are a bit too small for the pi on 2. It always happens with like a fraction. These brackets, they're not like the right size. And LaTex has a way of getting around this. So it's basically, the command is like backslash left and then backslash right. But then, oh, sorry. Yeah. And then you put one bracket there and one bracket there. And what that does is it will change the size of the bracket depending on what you put into your equation. So I can show you this by, let's start a new environment. I'm going to do a line. So if I go frac 1 on 2, and I just put on either side. So on this side, we need the left bracket. So backslash left the bracket, and then backslash right the end bracket. Let's see what that looks like. Yeah, so as you can see, I'll delete that there because that's not right. But as you can see, the bracket will automatically adjust itself. So if I have something inside the bracket that's just like 1, now the bracket has shrunk. So it's kind of easier to use that like bracketing style by default instead of using like these traditional brackets, because this way it's going to be like the right format either way. And this like backslash left and backslash right command doesn't just work for brackets, it also works for like square brackets. Let's go frac again. Just 1/2. Yeah, as you can see now, it would like dynamically adjust the size of the square brackets. It also works for curly brackets, but curly brackets are a little different because, as you can see, every command in here uses a curly bracket. LaTeX has a hard time deciphering whether it's like a bracket that you want to put into your document or a bracket that's like a part of the code. And the way that we denote the difference is just with another backslash. So you have to put another backslash in front of the curly bracket for it to actually show up. Yeah, so that's how you make the big curly brackets. So I'm going to write a note. Okay. Backslash left and right will adjust the bracket size. So backslash left and right adjusts the size, and to use curly brackets, you need a extra backslash. Okay, and I'll just hit recompile to make sure that shows up. Yeah, so hopefully that bracket stuff wasn't too confusing. I was just gonna say one more small thing, and then I think it will be time for a break. Let's see. Oh no, it's actually challenge time and then break time. So the next thing I was gonna say is just like LaTeX is a case-sensitive coding language. Like it's barely a coding language, but it is case-sensitive. So as we saw before, I'm gonna put this in a equation environment. We could get any like Greek letter we wanted by just going backslash and then their name. Let me go gamma, pi. And the way you actually get the capital letter of that is just by capitalizing. And this is convention for pretty much everything in LaTeX is like, if you want to use the capital version, you have to capitalize the first letter. Let me write a note about that. To use capital letters, capitalize the command. Okay, so hopefully that is all not too confusing. I know it can be a lot at once. So what we're going to do now is like a little bit of a challenge, but it's no big deal if you don't know how to do it. So there's like two challenges. The first one is just typesetting sine pi on 3, root 3 on 2. And then the second one is kind of like the extension one. It's the normal distribution. I will give you guys access to the cheat sheet before I force you to do this challenge. This cheat sheet was made by the LaTeX trainer before me. Her name's Miriam, so all credits to her for making this. And it's got way more than all we've covered today. Like it's got a ton of stuff. I think the math section is just over here, but it could be good to explore. So I'll give you guys the link to download that if you'd like. There's the access to the cheat sheet. And then I'll give you around like 5 to 10 minutes to do this challenge. I'll put it back up. And then we'll go through it at the end. That is not the challenge. There we go. You can put it into the align environment if you'd like, but you can also do them as separate. It doesn't matter too much. But yeah, I'll give you 5 to 10 minutes. And if you think you've got the answer, you feel free to put it into the chat. Oh, okay. I think we've got a solution. I'll put this up and let's have a look. Yeah, that looks really good. That looks perfect. Yeah, that looks great. Yeah, I was gonna go through the solution, but like that, you're all over it. So, yeah, that's perfect. So now we've got like a bit of a scheduled break. Um, so yeah, what time is it now? It's like 11:43. So we'll take like a 10-minute break and we'll come back at like 11:53, basically. Yeah. Um, I'll write that here. So 11:53. Okay, it's 12:53. Let's continue with the workshop. There's not too much content left. I wanted to show you one more like typesetting trick, I guess. Like if you ever want to typeset like a piecewise function with the big bracket, there's like a built-in command for it. Um, so basically it's like a combination of the align mode and uh, it's a combination of a few environments, let's say that. So first we can just begin a normal application. And then to do this, we actually need to embed a environment inside of another environment. And you'll see this later on down the track that it's pretty common. But I'm going to write f of x just for the function f of x equals. And now to put everything in that big bracket, we have to do this environment called cases. So begin. And then, so now we've got this like nested environment situation going on. So inside the cases environment, it kind of behaves similar to the align. So what were we saying? What are we doing here? An indicator function, sure. So we're going to say 0 if x is in, we should probably say 1 for x is in A. That sounds more correct. And then to do the new line, double backslash, 0, and then for x, sorry, this is meant to be a backslash in. That's how you get the element symbol. And then to do x not in A, you go x, and then the not symbol is kind of unique. It basically will put like a slash through anything that you put after it. So we can do x not in A. And let's hit recompile. Yeah, so there you go. So what's kind of going on here is like a environment inside an environment, and then in here is kind of similar to a line where you have to use the double backslash. So this is a example nested. And yeah, if you do like more complex typesetting, this will come up a lot. But I'm also going to name this section. There we go. So now I wanted to talk about a few like little tips and tricks that you can use with LaTeX. The first one is detexify. So this one is this is just like a website. oh, I'm getting an ad. I'll put the link for it in the chat so you can also have a play with it. But I'll show you how it works. Basically in LaTeX, if you can't remember the command for a symbol, you can draw it in here. So maybe I don't remember how to do greater or equal than. And what it does is it tells you like the command for it, and it also tells you what package you need to have installed. So this one we need AMS-sim, which we do have, so that's good. There's all sorts of weird things in here. I think there's a bat, but I don't really know how to draw a bat. Oh god. Okay, there is a bat. That probably, yeah, no, I didn't think it was a bat. But there's like a heart, I believe. I think, hopefully. Yeah, there's a heart. It's a heart suit. Let's see if we can use it actually. I was going to use that one there. Oh, I have to use a package. Okay, heart suit it is. Yeah, there we go. We got the heart. But yeah, so it also tells you like what environment it's in. So that's math mode. So that's why we needed the dollar signs. Text mode is just like the normal mode, so you don't have to worry about that. So that's a good little trick to have in mind. Also, if you're ever typesetting in LaTeX, there's a lot of websites and a lot of other software uses like LaTeX language. So Wikipedia, for example, oh, what has happened to this Wikipedia page? Theorem wiki. If you ever see an equation on Wikipedia, you can actually copy and paste it straight into LaTeX. So I'm just gonna show that here. If I copy and paste that, I'm gonna name this section like tips. You have to put it in math mode still. Just copy and paste that. Oh dear. Okay, I don't know what this is, so I'm gonna delete that. I'm accidentally hit that. Let's get rid of all of this. Okay, but you can see the math itself is actually in LaTeX. So yeah, like it just helps if you have a massive equation, you don't want to typeset everything, you just can go into Wiki, copy and paste it. I think similarly, Desmos is also pretty common. Like I prepared this earlier, but I just graphed something in Desmos. Yeah, it also uses LaTeX to encode it. So see, begin equation. Yeah, so now saves you a lot of time. I believe in Mathematica as well, there is, when you go to copy and paste, there is a copy in LaTeX mode as well, which is also really helpful if you're using Mathematica. So lots of software is encoded. Just hit recompile. Okay, and then now onto like the last little bit of our content today. It's just called, I think, macroing. So what macroing is you get to create your own custom shortcuts and commands. I will show you, I'll show you what my normal macros look like. If I just go into one of my notes. But yeah, so this is my normal style sheet. As you can see, there are a lot of like new commands, and like a lot of these commands in LaTeX, they're pretty long, they're a bit clunky. What you can do is like you make a shortcut, you can use the shortcut instead. So for example, when we did these brackets earlier, right, we had to do backslash left bracket, backslash right bracket. There's a lot to type. So we can make a shortcut for it. And the way we do this is you want to put it into the same bit where you did like the packages. Like the style sheet, it kind of controls the formatting of the document itself. So it's kind of like the control center. So I'm going to make a note that says shortcuts. And the way we make these shortcuts is backslash new command. So I'm going to click the first thing that comes up here. As you can see, it comes with like curly brackets, square brackets, curly brackets. So this first bracket here is what we're going to name our command. So let's name like the curly, like the big brackets, parentheses. So I normally go like backslash paren, short for parentheses. So to actually use our function, we have to type this. This in here denotes how many like arguments your function is going to take. So we only need like one argument because we just need one thing inside the brackets. So you just put one, and then this final bracket here is where we put the actual code for it. So if you remember, we went backslash left bracket and then backslash right in the other bracket. I'll make this a bit bigger so we can see. And then we need to specify where we're putting our argument. And the way we do this is we go #1. So the reason this is square is because it's a optional argument. If we didn't have this, by default, it will just be like, okay, there's one argument, but we can put it in. And then we're just saying that this is where we want it to go in the code. If you have, sorry, there's no hashtag there, but if you had two, you might have to go like, oh, and then hashtag two goes there. But we've just got one for now. So I'll hit recompile. Okay, so we've got this command set up. And let's just go down here, go begin equation, and two, and then we go backslash paren or whatever we have named it. So let's have a look at what that looks like. Oh, a good tip with like navigating, because when this gets super long and this gets super long, it's hard to match them up. You can use these little arrows. Also, if you double click, it will take you to the code location, like double clicking here. Yeah, so it helps, especially when it gets like super long and you're like, where is my stuff? And yeah, as you can see here, that was a shortcut that we made. So that definitely cuts down on a lot of time. Yeah, so normally I have like a bunch of different shortcuts. Like if you want to get the number for R in Reels, like the special R in Reels, it's I think it's like math cal R. Oh, that's not right. What is it? Oh, it's math BB. Math BBR. Which obviously that's pretty time consuming. So a good shortcut for that is this one here, like new command \r math BB. So I'll put this one into our style sheet and we can just also put it into the chat if you want to copy and paste it. So now instead we can just go \r and that's a lot faster. I've got a bunch of them for like every like reals, integers, natural numbers, complex, what's Q, rational, I think. So I'll put those into the chat if you'd like. It's just saves a little bit of time. There are some, I think I've got some other macro ideas. Oh, this one I quite like, pfrac. So this is like a combination of fractions and the aligned brackets. So that just, what is it? Oh, this one, big O notation. Thought that would be useful. Oh, curly bracket notation. That is something we'll come back to, especially because you have to go / curly to actually use the curly bracket. I'll have a look at the other. To do a partial D in differentiation, it's /partial, which is kind of long if you're doing a lot. So I've shortcut it to like \dd. Some of the epsilons are long. Oh, this one's cute, but it's a bit useless. I'll show you. I don't even remember why. It's a cute eye. Why did I do this? Oh, it's all of this. Yeah, okay. I must have just been really bored that day. Let's see what this looks like. Cute eye. Yeah, so it's an eye with a love heart on it. I'll put that into the chat as well. So a lot of customization with what you could do. There is one more kind of like thing you can cut. I mean, there's lots more things you custom, but this one is also quite important. If you've ever taken a like math class and you've seen their notes kind of written in this way, that's like definition and then followed by that kind of formatting. I think it's pretty common in like first year math classes. The way we create like new environments is you're going to style sheet. I'll show you on here actually, a very long style sheet. You use this command called new theorem. So \new theorem. And then this is just going to be like the name of the environment. So we can call it definition. And this so this is the word that you put into actually the code for it. So maybe we could do def to make it shorter. And then the second bit is what's actually going to appear. So it's called, let's capitalize it, definition. So if I go into just here, I go begin def. So we call it as you would call any other environment. And then you got the end def, definition of something. And then to put like the type, like the name of the definition, you just put it up here in curly, in school. What brackets are these? These are round brackets. So I'll just put something up there. And we'll hit recompile. Where is it? Where is it gone? Where have they put my... I'll just show you on here because there's more of it anyways. Oh yeah, so these are like commands, but they're the same thing as definitions. And the good thing about these is it will keep track of it for you. So as you can see, it's numbered it for me. Yeah, so those are like the useful ways you can customize your LaTeX. I do have a challenge. It's basically making a shortcut for doing the curly brackets. So I'll give you a little bit of time to do that, but just make sure you put it into the style sheet. And if you, oh, why is that not happy? Yeah, if you follow this sort of format, but yeah, just remember you have to do that for curly brackets instead. So it's a little tricky, but hopefully, yeah, I'll give you a bit of time. Oh, I'll put it back on the challenge. There we go. Oh, let's see. Oh, you've named it curl. I like that. What do I know? I think I normally name it set or something like that, but curl is a good idea. Yeah, that looks great. Let's just compile it anyways. So curl, just do a random set there. Yeah, that looks great. So yeah, a lot easier than having to, especially doing both sides of the brackets, I feel like is very time consuming. Okay, that is pretty much all the content we had today. I just made like a silly little review quiz. It's on quiz is. If I start it, sort of a little bit of a recap of the lesson. Yeah, if you want to do the quiz. Oh, there we go. Oh. So loud. Okay. Oh, nice. Yeah, that was pretty much everything that I had today. Thanks so much for coming. I do have a little feedback, like survey if you'd like to do it. But yeah, that was pretty much all. Thanks for coming. And yeah, feel free to